Hello again, it's me. Today we are going to build the original JyeTech DSO shell DSO 150 15001K do-it-yourself digital oscilloscope kit with housing. Why do they have easier names like do-it-yourself oscilloscope with housing? No, they have terrible. Okay, I ordered a while ago, so it was cheaper than the $21. I think I pay about $16 for it, but even for $21 it's okay. It's not a useful tool, so don't expect too much. It's a little bit like the DSO 138. Most of you know already. This is one of my DSO 138s I have. This I built in my iconic cases of real wood with the brown paint. You already see other things in this, especially the electronic load and the power supply I built 1 or 2 weeks ago. And yes, this is a finished shell, so I don't need to build one of my cases around. And one reason I get it is this has the Rotary Encoder for setting up or for changing things. I think this is much easier than the buttons in the 138. The rest of the specs are almost the same, and here you see why I get a laptop underneath the camera so I can scroll down to the specs. It is also 0 to 200 kilohertz. It's a little bit above the audio frequency range. Sensitive is about 5 millivolt per division and up to 20 volt per division. That is not bad. They say resolution 12-bit. That would be better than my oscilloscope here in the lab. Real-time sampling rate is 1 megasample per second. That is, yeah, I'm not sure if this is also true, but I think they are not lying or telling you something else. It's not a rip-off thing, it's just what it is. And the record length is 1024 samples. That is really not high, so don't expect too much. The power, it has no built-in battery. I think I would like a bigger shell with a built-in battery or an option to build in a lithium battery. I didn't build it yet. Maybe there is a way to put in a small lithium battery, but with 120 milliamp power consumption, it could be a little bit difficult to get a too small battery, because when you think about this here, this power bank is about, the real capacity is about 1000 at milliamp hours at 3.7 volt. If you 3 times, then about 300 maybe left. So you can run it ideally 2 hours or less from the battery like this, and it's quite big already. And yeah, that is all for this part of the video. And next part is I opening the box. But for this I have to remove the laptop. But this is quite easy. Just make like this. There you see underneath. My old way to present you a kit. I put a paper underneath. So this you don't need. Also go away. I zoom out a little bit. Adjust the mate here. Turning up the power for the lamp. Making more light, much more light. By the way, I'm using the just built power supply because it's not so noisy than my big one. I hope the fan doesn't went on. Then it's also loud. You will hear it. Okay, doesn't matter. When it's getting loud, the fan just run. So here's the box. Yes, it is a box, and that is something really unusual for the Chinese kits. Normally they come in these plastic bags. Nothing else. I can show you. I have more laying around here in the lab. Maybe this one. Yeah. This is the way they normally come. Only a plastic bag wrapped in a big piece of bubble wraps, and that is how you get a kit from the Chinese. But hey, it worked. And the fan goes on. Yeah, I still have to work on it, on the power for my light. And my light situation I really don't like. So if you have any idea from me or a good tip what I can do with better light, please leave me a comment there under the box, no, under the video maybe. And you know what I want to say, but normally it looks cool when people pointing. Not when I'm doing it. Okay, so this kit comes in the box. That was quite surprising, and I like it. Yes, you have a box to put away, not the plastic bags. And you see, I'm very easy to make me happy. So, box goes there. Opening, what's inside? They provide also a manual. That is the next really unusual thing for the Chinese kids, that they have a manual. I don't put it above here. You see the light coming in, and yeah, it's getting messy. But doesn't matter. They come with a manual. They told you how to solder it. And I think I will use the manual. I'll put the manual and use it. Going step by step. Why not? You'll see. And maybe it's too boring and I go back to the other way. Just throw in the parts and see what happened. The manual has 2 pages. Also the sampling of the kit. And one problem I think is I read about the Rotary Encoder, how to fix it. It should be not so easy. Yeah, we will see. Maybe I mess it up totally. Doesn't matter. So, what else? The test lead, the probe. Yeah, it doesn't look like an oscilloscope probe, and I really have a lot of them laying around now, but doesn't matter. And for a nice view, maybe for the video title, we try to arrange it nicely. Next up, a bag. Oh yeah, and here you see the reflection of the light. And the fan is going on again. Oh shit. Sorry. I really have to think about how to do it. This is the back. It has one board, a second board with the display. I think I have to handle this a little bit with care so it doesn't broke the cable to the display. So I think the fan is not so necessary. I stop the video here, pause it, and I'm back in a few seconds. I just open the case and rip off the fan. If it burns, doesn't matter. So go ahead. I just put in a bigger fan running at low speed, so I hope the power supply will keep the video with lighting. Yes, again, the topic lighting, I really have problems with it. Between the casing things and the small parts, they put even a small piece of foam, so nothing broke. Very nice. Maybe should also put it in the video up there. Yes, why not? And this is a cable from the light. We need to get more professional, I think. So now pieces of the case, also called pieces. Yes. This is 2 parts. This is the front. This is the outer casing from the upper part. Don't know how to say it. Just put it back there. Goes there. No. Goes there. Looks nice. Then a bag with small parts. Tons of small parts. I didn't get it out yet. Get it out later. Put it there. There. Hey. Doesn't matter. Get them out. Get the small parts out. And some screws. Looks more nice. Then 2 more plastic pieces. Putting them there. No, it's upside down. Putting there and there. And at least out of the box, the back side. The back. Yes, that's all. What else do we need to build it? We need a soldering iron. I'm using again my Erza Icon Pico. Then the side cutter, I call it side cutter, Seitenschneider in Deutsch, to cut the leads of the components. Zange. I always call it Flachzange. I don't know the English name, so just something to bend the leads if I don't put it just through. Okay. What else? Getting out a multimeter to check the values of the resistors, because I'm too lazy bone to read the color codes. And I also read about that the color codes of these resistors are not very easy to read. And because I like the size, I'm using the AN8008. It's so a small little multimeter. I like to use it, put it there, and I need to prepare the manual. First step 3 on this page. No, I want to use step 1. And what does step 1 say? Check the mainboard. Apply power. Oh. Okay, I can already apply power. Well, let's do it. If they say step 1, apply power, we will apply power. Apply. We will put power in it, and I think this is 12 volt. Should I check it? Let's see if it fit. It fit! And we already have light. And something switch on, DSO shell. Great, we already have something on the screen without any other parts. Yes. Step 1 finished. Go ahead with step number 2. Test signal terminal, power connectional optional, slide switch, pin header, tech switch, remove resistor R30. Step 2, assembly analog board. Assembly the main board. Okay, I get my chair and start. So, it's time to get started to solder. I will make time-lapse of this because I really don't know what to babble all the time, and I'm not sure if you like to watch the video. First step, they say bend the test signal lead connector like this, so the feed's 90 degrees. Yeah, okay. Put it in at the test signal place. This is there, and solder it in place. Quite easy. I put underneath so it's easier, doesn't fall down. I don't think that I need flux for this kit through all parts. I'm usually not using flux. Normally other kits, especially the SMD kits, I'm using flux, but for this I think it's okay without flux. And I need to organize my things here, where to put them. The iron goes to standby. So, need to warm it up. Yes, work already. The manual need to go somewhere else. I'm really afraid that you see my hair, my head, when I go too close. Yeah, very nice. And I cut the leads. No, I don't need to cut them flush because here a lot of parts underneath higher than this. So, second thing I have to solder in is the power connector optional. I don't need it, but something I have to do is the display is flapping around. I don't like it. I'm afraid I will break the display. So, while mounting it, I just save it with a piece of tape. So, you see the big reflection there. Just will secure it with a piece of black tape, so later I can remove it. Next step, slide switch. They have two different kinds. Smaller one, a bigger one. Let me see which one fits there. This has the 3 settings. This has the power switch has 1. So this goes in there. And this is quite easy. Just press it in and it's good. So I will put solder on one pin and then check the position. I will check position. The position. If it is flush, yes, it's flush. So I can solder the rest. See, I'm touching the pin of the component and also the solder pad on the PCB. Heat them both, put some solder, wait for a while, and then just lift the soldering iron. And hopefully I have nice solder joints. And to be honest, it looks good. I make a good job, yes. Next, pin header J2. It's 1x4, 1 row, 4 pins, and it goes where the rotary encoder is, but I'm not sure from the picture. Yeah, and here's also some people make wrong. They solder it on the wrong side. It has to be here. This is also part. I solder one leg, even with not so much solder. Check the alignment. Heat it up again and the alignment to align it well. Yeah, I need to concentrate for a second. So, the alignment is well enough, should I say maybe. And then, the same procedure, heat the pin, heat the pad at the same time, put some solder. There was a little bit less. And here you also feel the thermal mass, there's more material, more metal, and it sucks up the heat, so you can feel that it takes longer to solder. Okay, next step is the tactile switches. 1, 2, 3, and 4. 1, 2, 3, and 4. Here there is no... they feel great. Not these small ones, a little bit bigger ones. Just press it in. Just now, the building goes well, not bad. Well enough. The last one, the pins are not perfect, so I need to align it. So, turn it around, try to hold them. And also the switches, I want to have them aligned very nice later. So I only put solder and not too much solder on only one pin of them. Then I can turn it around, heat the pin up again while I'm pressing on the switch, so it is flush to the front and doesn't come up. This one doesn't want to solder. Need to check it later. And here also. So now time for the rest of the legs. 4 of each, 16. 16 solder joints. So also here, heating up the solder pad and the pin of the component of the switch in this case at the same time, and then just put your solder on it, and that is how it works. Don't forget to clean the soldering iron from time to time. It helps a lot. This one doesn't want, so I turn it around to get it in a better position for me. Better position to hold the soldering iron. Sometimes you have to go around to find a good position. This one was also a little bit tricky. This one was quite easy. There's not enough solder from the beginning. So all the 4 switches are mounted, and I don't need to cut them because they are the larger parts. They're parts that are much longer than those, so I don't need to cut them. Maybe I do it later if I figure out if I can put a battery in. So that was the no Apple Power JyeTech power switch and face buttons for their operation. We move resistor R30. R30 is used to bypass switch 5, so the member can be tested without the power switch. Okay, they really got a big effort to make it like this. So R30 should be somewhere on the picture. There should be close to there, yeah, to the power inlet. It is there. I could use the hot air gun, but for this little 0 ohm resistor, yeah, they put it there to bypass the power switch for the test mode. Yeah, that is good enough. It's gone. And then you should test it again. Plug in the 12 volt. Power switch work. And you also should check the buttons here if they do something. Yeah, they do something. Okay, work. Step 1, 2, 3, 4, 5. No, step 1 to 17 finished. Step 2. Step 2, resistors. Note, always meter resistors values before soldering. Yes, we will meter them out. We have a bunch of them, 15, 16, or 16, and they go to the analog board. Analog board is this, and I zoom in a little bit so you see more of it. Okay, I think this is closest I can bring you, but yeah, just there is totally the light. Wait, if I can adjust it better for you. No, doesn't matter, doesn't work better. That is a little bit feel too much of those. Turn down the light. If I'm doing it here, it's maybe better. So then let's see which one we get. I just measure one, then I check the number where it goes. $150K. 150K. 150K. They have a 130K. Should measure again. Maybe I make something wrong. Maybe I should read. Oh, it's 150 ohm. Yeah, better double check. 150 ohm is R8 and R16. I start with the lower number. Lower number is R8. I don't solder it yet. I just find a place where it goes. Stick it through the board. Try to stick it down. And then I'm using this. Just like this. So, yes, one R8. Next one. This is really not a funny work, I'm telling you. 5 point something meg. 5.1 meg. There's 5.2 there, but this is a high value resistor. So this is R2. R2D2. R2. R2. R3. R2 is here, up here. Throw it in. Ventilates like this. Go ahead, next one. Oh my gosh, at this speed it takes hours to finish. 300 ohm. R7. Welcome, R7. R7, you are welcome. And you go there. Yes. Flop. Flop. I like when they are flush on the board, and this is the best way. So, go ahead. And you are 3K. 3K is R13. R13. 14, 15, 13. And Okay, the same. Yes. Next one. About 11K. Do they have 11K? Yes, they have. R4. Most of the components designators are now on Kopf or on the side, or a little bit difficult to read. R4 is here, but I managed to find place for R4. Just like this and like this. Yes, so still a lot. Getting boring. 93 ohm. I think this is 100. Nee, 91. They have a 91 ohm resistor there. I think this one. It's R9. Yes, it's there. And bend it like this, so they don't fall off. Still so many. One is enough. 1K. Yes. R5, R6, R14. Let me see if there's still R5. Yes. R5 is here. And next one. 15 ohm, 15 ohm, R11, R12. Not sure if I already get one of those. R11 and R12. No, there. One of them goes there. And also here, bend the leads so they don't fall off. Next step. We have a 1K again. 1K was R5, R6 and R14. And somewhere was R6 there. Sorry, should not sing. I should not make you up. 1K again. The last 1Ks are 14. R14. Just feel like this game or people playing where other people call numbers, and yeah, I only see it in the US television things. I don't think that we have it in Germany. I'm not sure if you have this game in Germany. Maybe not. So I have to hurry a little bit. We have almost 12:30. In about 1 hour I have to get up my little from the kindergarten. Yes, Sophia is in kindergarten now and she has a lot of fun there. This is 30 ohm, about 30 ohm is R10. R number 10. R10 is there. That is why I have time at the moment sometimes. Except we are planning other projects, like this weekend we renew the kitchen. To be honest, we only hang the shelves from one side to another side, cut one table smaller so we can eat in the kitchen. This is 510K, it's R1, and it would goes much faster if I'm not talking. Yes, I know, maybe someone will complain. Why you are talking, guy? Just solder. Okay, I'll do the soldering. I try to keep in the picture, not sure. And to be honest, I'm wondering that not more people are complaining about the videos, about this crap quality. Yes. If you want to complain, complain. Doesn't matter. I won't stop. as long as I have fun and only one of you have fun, I will continue. Yes, I'm feeling like a star already. 200 something people just abonned, sign, not liked, sign, press abo, press the, yeah, I don't know the English. And that's great. Can't believe that 200 people already do this. So funny. Not funny. I really appreciate it that people like my videos. So, and if you don't like, it's also okay. I would understand if you don't like me just bubbling around and with a lot of nonsense. When I talk, I forget what I do. This should be the 1.2 and this should be R3, yes. Double check before it burns. I know most of you would like to see when it burns. That is why I look Big Clive. Oh, no. Big Clive is great. He makes great videos with a very good quality and his content, what he say is very interesting. Yes. And so, but his soldering technique, how he solders, insane. I don't know how he do it. I can't do it like this. This is again 130 ohm is R15, but I think I already put R15. I'm sure I already put R15. No, and still left. Don't know why I thought I put R15 already, but it's still left. Yeah, he's not like the high-tech things that Dave Jones make, but he make it very understandable, and so it's very good. 15 ohm again. R11, R12. So if the one left is R11 or R12, then everything went fine, and it's R12, so it's not wrong, but I should turn it around, then it is in the same direction. Then his brother or sister, her brother, her sister, is it he or she, the resistor. So everything in place. Time for the iron. The iron has to heat up, it's cool down, because it takes a while to put all the parts in. And we are already at minute 21. Oh my gosh. I think you will bored to death. And let me see, I want to try something different with this. Try to put the solder from above. Yes. Because it's plated through hole, I could also apply the solder from this side. And the reason is I do it like this. I can cut it more flush underneath later. And the legs from the components are not sticking around, and I have difficult to find a good place to put the solder iron in. So I make it from this side. It's much easier, except holding it It's a little bit difficult because I don't like when the board and the PCB is moving. But to be honest, it works very well. And this is halfway to big live soldering way, holding the PCB with the same hand than the solder itself. But he will not need something to support. He just hold it, and that is really, don't know how he make it. And someone else I like is this guy I found some weeks ago. It's Electro Boom. He has millions of subscribers, but I think because of often something explode in his videos or he get hurt himself. But looks like he has a lot of knowledge about electricity things, about the high power stuff, and yeah, very nice videos what he do. Very teaching. He also do a soldering video just now, and yes, I thought, oh, okay, the 1 Tesla coil kit. But I have no use for Tesla coil. I'm not so interested in the high voltage stuff, because I'm afraid to kill myself. Something is making noise here. I'm not sure what this peeping was. My phone? No. Normally you should hold those little bastards because they can fly around everywhere where you don't want them. But it goes very well, and just on the ground. Yes, very flat, and don't cut myself with it. Sometimes when I do this I cut myself. So next one, ceramic capacitors. 4 of them. 0.1 microfarad should be C1, should be this one. 330 pico, 331 should be, this is C2. The peeping was the multimeter. 151 should be 150 pico, this is C6. And then this should be 1 pico, yes. Okay, don't need to check this. Yeah, so just put them in. And this I will solder from underneath, I think. C1. Where is C1? There. C1, C2, 3 something something. C2 is here. And this piece is just held by friction, so I don't need to bend the legs too bad. Yes. The 1 pico, 1 path. I think 1 path, I would say 1 pico, because this is what I learned. I never learned the English words for some of those. But I should make the numbers, the the place where you can read the numbers on the component to one direction. Yeah, that would get, you will lose points if you make this in the, when you make the education, no, the Ausbildung. I make Ausbildung zum Energieanlagenelektroniker. Long time ago. over 20 years ago, and I learned what you should not do, and now I'm just doing it because I want to finish fast. Don't want to make it too pity. It should work. That is enough. Remember my name. I call it Quick and Dirty. And first name was my name, but I'm thinking about Quick and Dirty is a little bit too long name, and so maybe I renamed the channel to JyeTech, Singer Technology. But I cannot use Singer because Singer is already a brand name of a US company building sewing machines. Yeah, too bad I'm not someone of their... Yes, I'm not in this family. Oh, it'd be great then. Don't need to work. So, yes, that is the board. Slide switch, another switch. We like switches. The switch goes also to this side. This is the input coupling switch. You can switch the input coupling with this switch between AC, DC and ground. Also here, I started with one leg. And this is a high thermal mass. The switch has a very high thermal mass, so it is flat to the ground. Because of the metal case, this switch has a high thermal mass, and I can really feel like temperature drop from the iron, and it takes a while to heat it up to bring it to a good temperature to solder, and it has a fine pitch, so to concentrate for a while. But also works well. Yes, electrolytic capacitors. Yes, good. Elko. We call it Elko. E-L-K-O. Not for knockout. So, must be the same. 100 micro, 16 volt. Long leg should be plus. Yes, long leg is plus. Short leg is minus, and also minus is marked. And they have a marking on the board. 1. And they are the highest part, so I just can leave them in. 2, 3. Check again. Plus, long. Okay. But also here I will put solder on one leg, so I can turn it around and can check the position. No, it's really bad position. I want to have them flush on the board. So press on the component from the back and bring it to the right position. Yes. Now they are sitting very tight and flush. And to reach the components better, make it easier, I already cut the leads I don't need. So, next, the Bnc connector. Bnc. My one is a little bit, how to say? No, the thicker pins need to heat up longer to get good soldering results. Thank you that you write it. Yes, we know, it's a thermal mass. So, that's why I should start with the little one. This pin. Oh, this pin sucks a lot of heat, to be honest. But it goes through very well. And now, I tell you something. Before I touch it, I check the temperature. It's 372 degrees. now I touch the point and it's going down to 360, 363, 362. So this is because of the thermal mass. All of the heat from the iron is sucked out to this thing. Other side should be much easier. And after I will touch it again. Yeah. My little Erza Pico has really a hard time with these connections to solder them nicely. It has not so much thermal mass. Oh, careful, don't burn my fingers. Now, pin header. The pin header goes on this side. And again, this is one part. I will start with one leg. Then turn it around. Press it against. Oh, the Bnc is still quite hot. I was wondering why it's getting hot. I was soldering the opposite direction. So, it's flush, nice place, time to solder it. Need to go from this side. Yes, done. Finished. Step 2.6 finished. Second page. Page number 2. Step 3. Solder rotary encoder. Okay, this goes there. There's a rotary encoder. Mount a smaller PCB. Printed circuit board. Mount to the small PCB. Note, please pay attention to the orientation of PCB. Use the side with outline marking. Yeah, this is outline marking. There, I should just throw this in. Oopsala. Okay. This need to be a little bit. Yeah, but also without a road where I have to put it, I would always put it at the outline marking. So wondering why people wrote it is difficult. Maybe they have a mistake in their marking or in their manual, and I should really put it in the other way. Yeah. Okay. Ha. I started with those contacts, then those contacts, and at least the thing with the high thermal mass again. So, last piece finished. And you can turn it. Wherever I want. Step 4. Okay, step 4. Assemble front module. Fit LCD to the front panel as shown below. Fold the mainboard over while keeping LCD in place. Mount rotary encoder board to the front plate with the squeeze and solder the board to J2 of the main board. Import. Make sure PC touch the front plate while doing C. Huh? No, just throwing together now. First test. Should be able to just put this through. Oh, I paused just now for a while. So, time for assemble. First step is I remove the protective plastic from the screen, because I already hold it together, and I think after I mount it, there's no way to remove it. So this fits well. Turn it around, put in the rotary, place the rotary encoder, and hold it with the two small screws. Yeah, quite easy. Number 1. Number 2. Now it should not fall apart anymore. Yes, it's very flat. So put some solder on it. Yippee-ki-yay, soldering. Yes. Now, next step. Put this into the... No, maybe I get this. Okay. Checking analog? No. We think it worked. We don't check anything more. Final assembly. Yes. Yes. Oh, yes. Analog board is there. 4 screws again. 1. Good, it's a little bit magnetic. 3, 2. Number 2, of course. 3. And 4. Ta-da. Fits. Combine. Make sure. Attach. Okay. Still not this. Okay. Oh, that is a little bit fit. Yes, that is a little bit difficult part, but the test signal connector is not. But there's a lot, to be honest. It's still a lot of space inside. It should be enough space to build in a lithium battery pack, I think. Yes. Oh. Okay. Outer shell. Ta-da! Yes, 4 screws on the back. 1. Can't be so difficult to put in a screw. It seems a bit difficult. Yeah, I'm doing the high-tech stuff and I'm not able to put in a screw. Okay. Everything inside. So let's feed in some power. Ground. Oh, okay. Now I should check my position. Maybe I have a little bit more cable here. So yes, it's showing something. I'm not sure if it works. I didn't adjust yet. Just plug in the test leads and just check the internal signal, and I'm going to AC coupling. So let's zoom in. Yes. Switch off this additional light. Maybe I can use this one. Yes, okay, just 5 millivolt. The time base. Yeah, doesn't look so bad. Trigger, auto, single, auto. Okay. Trigger level. Multi-sective. Trigger. Okay. And when I press long there, I get some values there. Oh, that's done. I would say this is done. It's finished. Nothing is broken. My power supply works very well all the time, especially with the new fan, that it doesn't run so loud. And the DSO shell kit from JyeTech works nice. And I think there's enough place to build in a small battery. I really would like to have it battery powered. Yes. Okay. See you again soon with the next video. And really, I'm not sure what I should build next time. I have enough kits laying around here. So don't worry, you will see more. If you want, of course. And really, have any tip for me for my light, for this thing with the light. I really don't like it. It's really not so nice. Okay. Bye bye, guys. That's all. Oh, I should